Okay, so now that we know how to find limits, let's connect the idea of limits to finding gradients of tangents. Okay? Um, so my goal here is to find the slope of the tangent to f of x at x equals 1. Okay, so here I have this curve. This is f of x. And I have at x equals 1, okay, I want to find this the slope of this tangent. Okay, remember that, sorry, I may not have clarified this, but gradient is the same as the slope. Okay, these are the same thing here. Gradients and slopes are the same. Okay, so I want to find the slope of this line because that number will tell me how steep this curve is. Okay, so what I'm going to do is I'm going to create a secant line. A secant line is a line that connects, that crosses a curve at 2 points. Okay, and I'm going to find this line, and I'm going to find the slope of this line because I know that these 2 points are on this curve. I'm going to create that slope equation, and then I'm going to bring it closer and closer and closer, move one point closer to the other point, so that as I move it closer, my line gets more and more like the tangent line. It's going to look more and more like the tangent line. Okay, so I'm going to take this point, I'm going to create the slope formula for it, and then I'm going to move this line closer until this secant line becomes basically the tangent line. Okay, so let's start by creating the secant line from x equals 1 to x equals a little bit over to x equals 1 plus h. And I'm doing this on purpose because we're going to be doing something with this h later. Okay, so we have 2 points. We have 1, f of 1, right? Because this is f. The y value here is just f of 1. And then the x value here is 1 plus h, and the y value here is f of 1 plus h. I would just be putting in 1 plus h into this point. Okay, so this is a segment fm, f to m. Okay, and now I have 2 points, so I can find the slope of these 2 points, of the line formed between these 2 points, right? How do I find the slope between 2 points? If you think back, it's y2 minus y1 over, excuse me, x2 minus x1. That's change in y over change in x. Okay? We should know this from previous years. Okay? So what's y2? Well, y2 would be the points that this is y2 right here. Okay? And this is x2. This is y1, and that's x1. Okay, so now I have these 4 values. I just plug it into this formula to get the gradient here. So this is y2 minus y1, x2 minus x1. Okay, notice here that this bottom part simplifies. 1 and minus 1 disappear to get h, and the top stays the same. Okay, now what I'm going to do here is I'm going to make h. In order to make this point move closer, since I've left it in terms of 1 and h, I can move this point closer and closer by making h smaller. Okay, so as I move this closer and closer, I'm essentially making h smaller, and that slope then becomes the slope of this tangent line. Okay, so the gradient of fm, the segment fm, becomes the gradient of the tangent at f. Okay, so hopefully this makes sense. You may need to re-watch this, or just write down some questions and ask me in class. But hopefully this makes sense to most of you. The gradient of fm, as I move closer, as my h gets smaller and smaller, this point moves down the curve, gets closer to the actual curve, the point that I'm interested in, and it forms a tangent line. Okay, so the gradient of the tangent at f actually is the limit as h approaches 0 of this expression. It's this expression up here that we found, um, but it's the limit of that as h gets smaller. So I make h smaller and smaller and smaller, and this is um, that gradient then becomes the gradient of the tangent line. Okay, and this is why we started talking about limits, is because we use the idea of limits to find the slope or the gradient of the tangent line at a particular point. All right, so let's actually use this here. Okay. All right, so the gradient, to generalize this more, okay, to generalize this form, we can actually say, instead of saying let's x be 1, instead of letting x be 1, we say let x be some constant a. Okay, so that means no matter what that x value is, I can find the limit at I can find the slope of the tangent at any point x equal to a. Okay, so that's really nice. This actually becomes a formula. Okay, it tells me the slope of the tangent line for any a value. Okay, so if I put a over here, it would find the slope right there. If I put a over here, okay, it would find the slope right here. Whoops, sorry, right here. Okay, so I could find the slope of the tangent line anywhere on this curve. Okay, which is really convenient because now I have some. It's a tool for me. Okay, so this form you will need to know, and you should definitely write down in your notes. Okay, let's try an example. Find the gradient of the tangent to f of x equals x squared at the point 2, 4. Okay, so if I were to draw the graph here, this would be my f of x equals x squared. I have to find the point 2, 4 first. So let's say this is 2 and this is 4. Okay, so this is a very large graph. There's 2 and there's my point f. Okay. Whoops. And oh man. Okay. And then the second point, m, okay, would be 2 plus h, a little bit over 2 plus h, and then the f of 2 plus h is 2 plus h squared, right? This is really just f of 2 plus h, okay? And since f of x is x squared, f of 2 plus h is 2 plus h squared, okay? So that's why we have this here. Okay, this is really just f of a plus h here, okay? So now that I have those 2 points, I have 2, 4, and I have 2 plus h and 2 plus h quantity squared. I now substitute all of that into my formula. Okay, so f of a plus h, or f of 2 plus h in this case, becomes 2 plus h squared. F of 2 becomes 4, okay, and the bottom just becomes h. Okay, it's just h because that's the definition. Okay, and now we can expand this, but notice I can't directly substitute. I try to solve the limit by putting 0 in, but I have a 0 in the denominator, so I have to get rid of this h from this expression by factoring out. And that's what I'm going to do. I expand this term, and it becomes 4 plus 4h plus h squared, right, minus 4. The 4's will cancel out, and I'm left with 4h plus h squared all over h. I factor the h out, and that h cancels out with the bottom, and so I'm left with 4 plus h. And now I can directly substitute 0 in and get 4. Okay, so this is the limit. This is the limit. That's what y value is being approached as I get closer and closer to x equals 2. As I get closer and closer to 2, the limit at that point will actually be 4. And what this means is, notice we didn't talk about it in terms of x approaching a number. We talked about it in terms of h approaching a number. And this formula is nice because it tells me the slope of the tangent line at any point on a curve. Okay? And in this case, the limit is 4. Okay? All right, so I know that was a lot, but basically we now know how to find how steep a curve is at a particular point because we use gradients of tangent lines, right? Of tangents to to help us determine how steep that curve is. Okay, in this case, the gradient was 4, so that slope, the slope of this line would be 4. The slope of this line is 4, and that 4 tells me how steep it is. Basically, the larger my slope is, the steeper it is, right? Okay. So hopefully you understand what tangent lines are and how they're used in calculus. How are they used? They are used to find how steep a curve is. And now you know how to find limits of various expressions. We talked about how to find the limit as x approaches some number of some expression. Okay, and we basically do substitution, or we do we have to eliminate the denominator before we substitute. Okay, and now you also know how to find gradients of tangents to curves by using the limits, and that was our this expression here. The limit as h approaches 0 of f of a, sorry, f of a plus h minus f of a all over h, where x is a. Okay? All right. Please write down any questions that you have about this, and we will talk about it